Hey guys, welcome back to my YouTube channel. I'm Sebata Adam, and we are still continuing our kidney disease detection project. And by now, we are going to describe how we have come up with the results in the model. For this case, we are going to first model training and cleaning. Model training and cleaning. This is our main topic today. And before cleaning, what we should do is to export the data, and we shall explain that later in the later slides. But we are going to talk about the heat map. The heat map is a two-dimensional presentation of information with the help of colors, as you are shown here. As you are seeing, we have different colors within this. A heat map can help us visualize simple or complex information in our data set. A simple heat map provides an animated visual summary of the information, which is to be used in the project, as we are showing here. We have the ID, age, blood pressure, aluminum, sugar rate, as all these attributes are arranged or are given in summary in the inside here. Then you have what we call the correlation matrix. This is a simple table showing the correlation coefficient between different variables, like how different variables are related to each other in the table. It is used to plot the heat map, as is shown above, like as you can see here, the correlation matrix. The ID, the age, the ID is correspondent to the age and a given point, and here we are arranging each variable with its own coefficients relative to the other variables in the table. Then you have what we call a box plot. It is a type of a chart that depicts or group or arranges a given group of data throughout their quartile. It has what we call the maximum and the minimum. What we call the third quartile, the first quartile, and the minimum. In the first quartile, this is where our outliers or the values are above the range, which cannot easily be plotted inside the box are lying. For this case, in the case of it has the minimum, as I shown here. It also has the first quartile, the medium, and the third quartile, which shows the data is divided into and used in the data set. This is what we call the box plot. These are the outliers. These are the values which are outside the range in a given data set. We have what we call the median, have what we call the maximum and the minimum. This is the outliers in the minimum. These are the outliers in the maximum. Then inside here we may have the interquartile. Then you have what we call the outliers, as I had been talked about. Outliers is a data point in the data set that's distant from all other observation. A data point that sits outside the overall or the range of values. The outliers can easily be identified using the box plot. For example, as I shown above, these are the outliers. These are values which are beyond the range of other values. And this can be removed. This are indicated before when we are cleaning the data. Then you have what we call illustration of trends and time. Since in my data set, I don't have any value which is correspondent to the time or which varies with a given amount of time, I didn't come up with an illustration of times and space. Since I don't have any variable which is relative to the time, this makes me unable to come up with the trend in the time space. Then have what we call feature independent plots. For feature independent plots, since my values or tables or variables in the table, which I'm going to use in my data set, are only dependent on each other so that we can classify them into classes, I didn't come up with the feature independent plots whereby each variable is of its own. Mine depend on each other so that we can predict the disease, whether the person, depending on the age, blood pressure, and other mineral salts within the body. Explore and cleaning your data. This is in order to come up with a heat map correlation, what we first do is to clean the data. But before cleaning the data, we have to explore it or find out which data has to be cleaned or which data has to be catered for in the cleaning. Check the percentage of missing values, that's the always. Check if the noise exists. The noise, these are the outliers. These are the values in the also the range. Data cleaning, the process of fixing or removing incorrect or corrupted data format or duplicating the data set. Mainly, it involves removing null values. That's why you are seeing our plots over charts are with fine numbers. We can fix cleaning by fix or remove outliers, handling missing data. Then we have what we call during training or validation or coming up with a test of a given model in order to come up with our test. Our model is not outfitted. This is how we are training that we sprint the data into train, validation, and test. The main idea of sprinting data into a validation is set to prevent our model from overfitting. The model become really good and classified. In overfitting, you are preventing our model from being biased, that the results can rate or it can come up with can even be real, not they are dependent. We make our values dependent. The sprinting of data helps us to build a model which is reliable because the model for that case is not biased. Fit any one initial model of your choice. For this case, when I was developing this model of kidney disease, I raised the random forest classification since I'm having different values which can easily be classified. We are going to consider the random forest classifier algorithm model since it involves both classifications. It involves classification due to its use of flexibility, have fruits its adoption and make it handle both classification and irrigation. Random forest have three main hyperparameters, which needs to be set before training. This includes nodes, the number of trees, and the number of features. The hyperparameters are going to be explained inside there. Then if here I come to hyperparameters. Hyperparameters is a parameter of a model whose value influences the learning process. We are making our model to learn so that it can come up with some prediction during the process. Hyperparameters are configured externally by starting the model or model learning or training process. Hyperparameters tuning is the process of finding the optimal hyperparameter for a given machine learning algorithm. However, for the random forest algorithm, I use the automated hyperparameter tuning, which involves the method in which the user defines a set of hyperparameters combination or a range of each hyperparameter. And this, I was able to come up with the following results in evaluation and testing. Since I divided my data, I was able to come up with a precision accuracy, F1 score, and the recall of our model. Validation set is a set of data used to train artificial intelligence with the goal of finding an optimized best model solution. This is used to find the precision F1 score and recall accuracy as I showed. While I calculated my precision, I got 0.94, which means it's 94.7% precise. Then I have what we call the recall. It is 0. The same thing. And then you have what we call the accuracy is 96.0%, and the F1 score is 94.47%. This is all the good summary of my model. And I would like you to comment, share, like, and comment. Thank you for listening.